All right, let's talk about one of the biggest game changers to hit the Angular framework in a long time: signals. If you've ever found yourself wrestling with state management, trying to make sure your UI updates when it's supposed to, then this is definitely for you.
So let's kick things off with a super common problem, one I'm sure we've all run into. Imagine a shopping cart. You've got 2 items, the price is right, the total is $100. You click Add another item. The quantity updates, but the total price? It's just stuck. Why? Well, at its core, it's because the total has no clue that it's supposed to react when the quantity changes.
And what's our usual fix for this? We end up writing all this extra code to manually trigger updates, right? We're trying to remember every little dependency, just hoping we didn't miss something. Honestly, it's a huge headache and a perfect recipe for hard-to-find bugs and just plain messy code.
This right here, this is the fundamental challenge of what we call reactivity. How do we build our apps so that data just flows? Where values update themselves automatically, the very instant their sources change. That's really the puzzle we're trying to solve. Well, Angular's answer to this puzzle is a really powerful and, frankly, super elegant solution called Signals. They're a brand new building block in the framework designed to tackle this reactivity problem from the ground up. And that's the core promise. Signals are built to handle all that complexity for you. You just need to define the relationships between your pieces of data, and Signals make sure that when one thing changes, everything that depends on it just updates automatically. So what exactly is a signal? The best way to think about it is not as the value itself, but more like a special container, a wrapper that holds the value. And the key thing is, this wrapper has a superpower. It can notify any other part of your app that's interested, hey, the value inside me just changed.
Now, because of this, we have to interact with them a little differently. You can't just use a plain old equals sign to assign a new value. Instead, you call a method like .set. And to read the value, you call it like a function. This whole getters-setter thing is the secret sauce. It's how Angular can perfectly track who is reading a value and who is setting it. It's how it builds its map of dependencies.
Okay, so let's get into the 2 main flavors of signals that Angular gives us. Understanding the difference between these two is absolutely crucial. First up, we've got the writable signal. This is your source of truth. It's a value that you create and that you control directly. Think of it like the quantity of an item in your shopping cart. It's the thing you change yourself.
And then we have the computed signal, and this is where the real magic starts to happen. A computed signal gets its value from a calculation that reads other signals. It's totally dependent, it's read-only, and it recalculates itself all on its own whenever the signals it depends on change.
Here's a really simple way to see the difference. Writable signals, they're the source. They're the things you set yourself. Computed signals, they're the result. They're derived from those other signals. You can't change a computed signal directly. It just knows how to figure itself out based on its dependencies.
So if we go back to our shopping cart problem, the solution becomes incredibly clean. Our total is now a computed signal. Its value is defined by one simple expression: the price signal's value times the quantity signal's value. That's it. Now, whenever price or quantity changes, total updates automatically. No more manual work.
Okay, so signals are amazing for calculating values that you show in your UI. But what if you need to do something else when a value changes? Something with a side effect, like logging a value to the console, or maybe making a network request.
Well, for that exact scenario, we have effects. An effect is basically a function you define that Angular will run automatically whenever any of the signals you read inside of it change. It's the perfect tool for connecting the reactive world of signals to the outside world.
Now, let's think about performance for a second. Imagine you have a button, and when you click it, your code updates 3 different signals, one right after the other, all in the same little block of code.
So here's a pop quiz. If you have a single effect that's watching all 3 of those signals, how many times do you think it's going to run after that one click? The obvious answer seems like 3 times, right? Once for each change.
But the answer, and this is one of the beautiful things about this system, is just once. How does it pull that off?
Well, Angular is really smart about this. Instead of firing off the effect immediately after the first change, it waits. It waits for all of your code in that moment to finish, it sees all 3 changes, bundles them together, and then runs the effect a single time. This batching is so important. It prevents a ton of unnecessary work and keeps your app feeling fast.
So we know signals are smart, but how does this magic actually work? How do computed signals and effects know what to watch? Well, it all comes down to one simple but really profound rule.
And here it is. This is the most important rule you need to remember. Angular's tracking is dynamic. It will only track a signal as a dependency if you actually read its value by calling its getter function. If you never call that getter, as far as Angular is concerned, it's not a dependency. Simple as that.
This leads to this amazing feature called dynamic tracking. For instance, look at this code. We've got a signal getter tucked away inside an if block. So what happens if that condition starts out as false? Let's walk through it. The code runs, but since the if condition is false, the signal's getter is never actually called. That means Angular doesn't track it as a dependency. So later on, when that signal's value changes somewhere else in the app, nothing happens. The computed value doesn't update. It will only start tracking and reacting once that condition becomes true and its value is finally read. It's incredibly efficient.
So let's just bring it all together. Signals give us this incredibly powerful, fine-grained system for reactivity. We use writable signals for our sources of truth, computed signals to derive new values from them, and effects for any side effects. And it's all held together by that one golden rule. Signals are only tracked when they are read.
This new model really does open up completely new ways of building efficient and reactive UIs in Angular. It makes state management way simpler and can get rid of a whole class of common bugs. So the only real question left is, what's the first part of your app that you're going to simplify with signals?